Welcome to yet another video from ICSK, and greetings to all the CBSE Class 12 students facing the examination. Hope your preparations are in full swing. Here are a few tips and highlights for the subject physics. Let's start with a few general instructions. As we all know, the question paper is out of 70 marks. It is divided into 5 sections. Section A comprising of 1 marker questions, 16 number. Section B, 2 markers, 5 in number. Section C, there are 7 case-based study question, 4 mark each, 2 case-based study questions are there. And the last, section 5, section E, 3 5-marker questions. Let us roughly divide the time allotted, the 3-hour time allotted. Let us roughly divide so that we know that we are safely able to verify the answer paper towards the end. Section A, the maximum time that we can allot should be not more than 40 minutes. So that section B, 2 markers, we can comfortably finish within 25 minutes. Bear in mind, section C, let us not take more than 50 minutes. Section D, 20 minutes. And section E should be completed within 30 minutes. So that towards the end of the paper, we comfortably get 15 minutes for verifying your answer paper. Before we start with the chapter-wise highlights of our portions of Part 1 and Part 2 reader, let me remind you, dear children, please attempt all the questions. Especially when it comes to MCQs, do not leave any question blank. All right? Can we start with the chapter-wise highlights of our Class 12th Physics? We start with the first unit of physics, Electrostatics, comprising of 2 chapters. Chapter 1, Electric Charges and Fields, and Chapter 2, Electrostatic Potential and Capacitance. Here, the most important topic, of course, is electric field and force between charges, Coulomb's law. It's very important that we know the derivation for electric field on the axial and equatorial line of an electric dipole. Then, of course, about the electric field lines. We have drawn quite a few patterns about the electric field lines for different charged bodies. Knowing the properties of these electric field lines, you should be able to draw the electric field lines for any charged bodies. We pass on to the next topic of the chapter, which is torque. Torque acting on an electric dipole. As we all know, from previous question papers, Gauss law and its related application is a very, very important topic. There are 3 applications of Gauss law that we have learned. Electric field due to a uniformly charged wire, field due to a spherical shell, and field due to a charged plane sheet. So we are using Gauss law and we are deriving the expressions for the same to find the electric field, and also ample number of numericals from this section is very, very common for the CBSE exam. So children, once again, I'm reminding you, Gauss law and its related applications, please go through once again. All right. We pass on to the second chapter of the same unit, electrostatic potential and capacitance. As we know, there are 3 fundamental physical aspects. Then comes equipotential surface, and after that, capacitance. So here, please remember one thing in mind. There are many related topics which all seems to be similar. You all must have done the same mistake over and over again throughout this year. There is a potential due to a point charge. There is potential energy of charges. There is potential due to a dipole. There is potential energy of a dipole. So please read the question paper and very carefully and then see which question is asked from this section. Equipotential surface. As we have done the electric field lines, we should be knowing what are equipotential surfaces, what are the properties of drawing equipotential surfaces. As you can see in the screen, we have drawn the equipotential surfaces for a point charge, for a uniform electric field. We have also learned the equipotential surface for a dipole, etc. So this topic, please learn carefully. We are passing on to the topic capacitors. I'm very sure that when you have been doing the topic capacitor, there are many aspects of the topic which is so much related to resistors. So capacitors, different types of capacitors, the filling of the plates between the capacitor with air, be it a dielectric, derivations of the same, and also combination of capacitors. You can see in the screen that we have just roughly marked capacitors which are arranged in series and parallel. What are the key points about capacitors arranged in series? As you can see, capacitors, when they are arranged in series, same charge will flow through all of the capacitors. Potential across each capacitor will be different. And what will be the total formula for capacitors in series? 1 by C equals 1 by C1 plus 1 by C2 plus 1 by C3. After that, we pass on to capacitors in parallel. When any number of capacitors are arranged in parallel, what will remain the same? Potential will remain the same. Charge, of course, will be split to different capacitors. Charge is different. What will be the total formula for capacitors when connected in parallel? C will be C1 plus C2 plus C3, etc. So learn the properties of capacitors when they are arranged in series and parallel. Only then we'll be able to know and do the grouping of capacitors, what will be the potential across different branches, what will be the charge across each capacitor, etc. Can we move on to the third chapter, current electricity? I feel that current electricity, the initial topics are very, very easy and manageable. We talk about drift speed, we talk about the relation between current and drift speed, and of course, resistivity. As you see in the screen behind, there are different types of graph associated with resistivity. Here I wish to tell you one point, dear students. If it is a graph-based question in physics, even if the shape of the graph is correct, if the physical quantities which are plotted along the x-axis and y-axis is not marked correctly, it doesn't make any sense at all. And one more point, what are the two aspects of any graph in physics? One is the slope of the graph and one will be the area under the graph. Let's come back to the topic. We were discussing about resistivity and the relation between resistivity and temperature. Temperature dependence of resistivity for different materials. We have for a conductor, we have for a semiconductor, we also have for alloys. Learn it and also learn the relation between resistivity and relaxation time. Let's talk about limitations of Ohm's law. What do you mean by limitations of Ohm's law? A law cannot have any limitation, but what we mean is the variation of Ohm's law behavior for different materials, be it a conductor, be it a semiconductor, be it a diode. These materials, if they vary from Ohm's law behavior, that's what we are going to learn as limitations of Ohm's law. Very important. And also the combination of resistors in series and parallel is a topic that we have already learned in 10th standard. But then what we need is to analyze resistors which are connected in series and parallel in combination circuits, so that when we apply Kirchhoff's laws, you can see in the screen that we have simply marked a network, an electrical network. When resistors are arranged in series and parallel, certain times the figures, the arrangement is not so simple for us to analyze the current flowing through each branch, the potential difference of each resistor, and all that. Then we know that for complicated circuits, we will be applying Kirchhoff's rules. What are the two rules? There is a junction rule and loop rule to analyze the circuits. Please practice on questions related with Kirchhoff's laws. All right. And of course, Wheatstone's bridge. Here again, many of us make mistakes of drawing the figure or the circuit of Kirchhoff's Wheatstone's bridge as shown in the screen behind. The figure will be marked correctly. Maybe even the direction of current will be marked correctly. But your equations that you are going to write to derive Wheatstone's balancing principle does not even match with your figure. We move on to the next unit, magnetic effects of current. Chapter 4 and Chapter 5. The first topic of Chapter 4 is magnetic field on the axis and center of a circular current carrying loop using Biot-Savart's law. The derivation as well as the numericals connected with the same is important. Pass on to the next topic, Ampere circuital law. Based on Ampere circuital law, we have calculation of magnetic field at a certain distance from a straight wire as well as a solenoid. The formula for magnetic field for a solenoid is very important. As you know, B equals mu naught Ni, and the formula is carried over even to the chapter Electromagnetic Induction. Particle entering a magnetic field. When a charged particle enters a magnetic field, it experiences a force. Formula F equals Q into V cross B. So according to the angle in which, or the angle it makes with the magnetic field, the way in which the charged particle moves is different. If it enters parallel to the field, no force experienced. If it enters perpendicular to the magnetic field, it traces out a circular path. If it enters in any other angle, it traces out a helical path. Formulas for radius, formula for finding the time period, very important. Force between parallel conductors carrying current in the same direction or opposite direction. Have you not noticed that most of the times the topic questions come, derivation come, and if derivation is asked, definitely they'll be asking you to define 1 ampere. We are defining ampere in the context of the expression for force per length experienced by two parallel conductors. Moving coil galvanometer, another important topic. You can see the figure of a moving coil galvanometer, principle involved, theory of a moving coil galvanometer. How can we convert the galvanometer into an ammeter and voltmeter? Very important. The formulas connecting the same also important. Magnetism and matter. Here, please learn correctly the different properties of dia, para and ferromagnets. These are the different magnetic materials. Have you not noticed that most of the properties associated with a diamagnetic material, exactly the opposite property has a paramagnet, the modification of field lines also accordingly, and whichever characteristic or property is exhibited by a paramagnetic sample much intensely is observed for a ferromagnetic sample. Electromagnetic induction and alternating current, the next unit. Both the chapters go together. Here we concentrate on the aspects of what is electromagnetic induction, Faraday's law and Lenz's law. What is electromagnetic induction, by the by? Whenever there is a change in magnetic field or magnetic flux, correctly speaking, linked with the circuit, an EMF and a current is induced in the circuit. That phenomenon is what is called as electromagnetic induction. On its own, if an EMF is induced, then we call it as self-induction. If in a neighboring coil, an EMF is induced, we call that as mutual induction. So it's easy to remember that the derivations for self-inductance of a solenoid, most of the formulas are repeated in mutual induction, replacing self-inductance with mutual inductance. Then we have the generator, AC generator, again another important topic, principle of AC generator, the theory behind what is AC generator and the different parts associated with it. Alternating current. This is a chapter that most of us shy away from, maybe because of the mathematical treatment, equations, but then I always feel that if we are very clear with the phasor diagram, the impedance diagram, and if we know all the formulas connected with the different circuits, we can easily manage with the chapter. What are the three basic circuits in this chapter? There is AC applied to a resistor, AC applied to a capacitor, and AC applied to an inductor. Correctly understand the difference between AC voltage and AC current, the phase angle between them, the phasor diagram and the impedance diagram. Alright, then you can easily manage with this topic. We have seen the impedance diagram and the phasor diagram as shown in the screen here, and also the topic resonance. There are many points associated with resonance in LCR circuit. The phase angle between current and voltage will be 0. The inductive reactance and the capacitive reactance will be the same. The current flowing through the circuit will be maximum. So we call LCR circuit as an acceptor circuit. The impedance is nothing but the resistance offered by the circuit elements to the flow of AC. Isn't that so? So if current is maximum, obviously the impedance will be a minimum. Transformer, of course, is a very simple topic. Here we see the figure of a transformer. There are two types of transformers, step up and step down transformer. Equations associated with that, easily we can manage with the numericals, and also the various energy losses and how can we overcome the energy losses in a transformer. We move on to the last chapter of part 1 reader, electromagnetic waves. Short chapter, minimum mark distribution, but important. The different components of electromagnetic spectrum. How are they arranged? What are the different components? Gamma rays, infrared, microwaves, ultraviolet, X-rays, arranged in a specific order. Isn't that what is called as the electromagnetic spectrum? We'll be learning the different uses, the production, detection of different components with their frequency and wavelength range, and also the equations governing the electric field and magnetic field part of the electromagnetic spectrum. Then it is easier, very easy to do the numericals connected with the scheme and also the displacement current. Dear students, I hope that I have covered the important topics associated with the part 1 reader. Thank you and all the best.
Now we'll start with our book 2. In book 2, our first chapter is ray optics. In ray optics, the important concept which comes is total internal reflection. Remember what is total internal reflection, what is critical angle, and always make sure the conditions for total internal reflection. Okay, so those topics please revise. And next comes our application of total internal reflection. One of the important application of total internal reflection is optical fiber. And in optical fiber, it is used in high-speed data transmission and also in medical examination. As a light pipe, we are using optical fiber. After optical total internal reflection, the next one is refraction at a spherical surface. Remember the formula for refraction at a spherical surface. Also the ray diagram for refraction at a spherical surface. Then comes a refraction through a lens and lens maker's formula. This is one of the important formula in ray optics. Next is a refraction through a prism. We should know the ray diagram of refraction through a prism, the derivation for refractive index in terms of minimum deviation and angle of a prism. That derivation is a must-learn derivation in ray optics. Optical instruments. In optical instruments, we have 3 optical instruments: simple microscope, compound microscope, and telescope. Remember to learn the magnification for compound microscope, magnification for telescope. Always the lens used in compound microscope should be of short focal length, both objective and eyepiece. Now we will move on to a telescope. In telescope, we are always preferred to get the final image at infinity. That arrangement is called normal adjustment position. And also remember the magnification for a telescope. And also the telescopes are classified into 2. One is reflecting type telescope, the other one is refracting type telescope. Remember the advantages of reflecting type telescope over refracting type telescope. In reflecting type telescope, there is no chromatic aberration, and the spherical aberration can be removed by using parabolic reflectors. Also, it can be supported from behind, and it is cheaper because grinding and polishing is required only on one surface. Now our next chapter is wave optics. In wave optics, we are starting with Huygens principle. And using Huygens principle, we are proving refraction of light and reflection of light using this Huygens principle. Those derivations we should learn. After Huygens principle, the next one is Young's double slit experiment, interference and diffraction. Remember the interference pattern as well as the diffraction pattern and the difference between the interference and diffraction pattern. Okay. In interference, the intensity of all the fringes remains the same, but in diffraction, the intensity varies. Intensity decreases as we move from the center of the screen towards the side. Also, the fringe width for interference, it's the same, but in diffraction, the fringe width varies. Also note the other points, the difference between interference and diffraction. Dual nature of radiation and matter. In dual nature of radiation and matter, we have 2 main topics. One is photoelectric effect and the second one is de Broglie relation. In photoelectric effect, you should remember the experimental study of photoelectric effect. And in experimental study of photoelectric effect, we have the graph showing the variation in intensity of light and photoelectric current. The next graph is the variation in collector plate potential and photoelectric current. That is also, we have two types. One is collector plate photoelectric current and collector plate potential for different intensities. And the next one is collector plate potential and photoelectric current for different frequencies. Also, the next graph is stopping potential versus frequency graph. In that graph, remember to note what is threshold frequency and also calculation of Planck's constant using the graph. Slope of this graph, that is slope of stopping potential versus frequency graph, will give the Planck's constant. Now the second part of dual nature, that is matter waves, wave nature of matter. In wave nature of matter, remember the equation for de Broglie wave, the relation for de Broglie wavelength in terms of potential, de Broglie wavelength in terms of kinetic energy, and de Broglie wavelength in terms of momentum. Numerical from this also can be asked for the exam. Atoms. Next chapter is atoms, and in atoms it starts with alpha particle scattering experiment. In alpha particle scattering experiment, you should know the experimental arrangement of alpha particle scattering experiment and also distance of closest approach and impact parameter. Those definitions also you should remember. Based on this only, we are deriving the expression for energy of electron, that is kinetic energy of electron in its orbit, potential energy and total energy. Remember, kinetic energy is negative of total energy and potential energy is twice the total energy. Okay. Next is a hydrogen spectrum. Hydrogen spectrum, you all know, we have Lyman series, Balmer, Paschen, bracket and Pfund in hydrogen spectrum, and Lyman falls in ultraviolet, Balmer falls in visible region, Paschen, bracket and Pfund, they all fall in infrared region. And also calculating the wavelength from hydrogen spectrum is also important. Bohr atom model. In Bohr atom model, you should remember the three postulates of Bohr atom model, and also the limitations of Bohr atom model is also important. Next is our nuclei. In nuclei, remember the equation for radius of a nuclei, and numerical based on that can also be asked based on the radius of nuclei. And remember, the next point is density of a nucleus. Density of a nucleus is always a constant. It won't vary. Then questions based on mass defect and binding energy is also very, very common. Binding energy curve. In binding energy curve, remember the possibility of nuclear fusion and nuclear fission based on binding energy curve. First, plotting a binding energy curve is important. You should label some of the elements in binding energy curve, and remember nuclear fusion based on binding energy curve. That is, light nuclei combine together to form heavy nucleus, liberating energy. And nuclear fission is heavy nucleus will split into lighter nuclei, liberating energy. Nuclear fission and nuclear fusion. Next is our nuclear force. Properties of nuclear force is required. It is charge independent. It is a short range force. It is stronger than electrostatic force and gravitational force. And the graph between potential energy and distance for nuclear force. Beyond a certain distance, nuclear force is attractive, but when it comes very close in very short range, the nuclear force will become a repulsive force. Last chapter of part 2 reader is semiconductor electronics. It is an easy chapter and it's a scoring chapter with very less numericals. Okay. So in semiconductor electronics, it starts with energy band diagram for insulators, semiconductors and conductors. Note down the energy gap in all the three. In insulators, energy gap is very large. Semiconductors, there is a small gap, less than 3 electron volt, and conductors, they are overlapping. Valence band and conduction band is overlapping in the case of conductors. Next is our extrinsic semiconductor. There are two types of extrinsic semiconductor, p-type and n-type. P-type semiconductor is doped. It is a semiconductor doped with trivalent impurity. N-type semiconductor is obtained by doping with the pentavalent impurity. Energy band diagrams of p-type and n-type semiconductor is also required. Now the next is a formation of p-n junction. In formation of p-n junction, we have two main processes involved in the formation of p-n junction. One is diffusion, second one is drift. Also remember, depletion region, and barrier potential. Next is the use of a PN junction. PN junction diode. Okay. In PN junction diode, we have forward characteristics and reverse characteristics. You should know the circuit diagram to study forward and reverse characteristics, and also the graph showing the variation in voltage with current in forward bias and reverse bias. Diode will conduct current in forward bias and it blocks the flow of current in reverse bias. And next is the application of a PN junction diode as a rectifier. We have half wave rectifier and full wave rectifier, both the circuit diagrams and also the waveform, input and output waveforms of half wave and full wave rectifier. Finally, always remember, do not leave any question unattempted. Also remember to draw or indicate the direction of light ray in ray diagrams and verify your answer before submitting the paper. So best wishes from ICSK Kuwait. Thank you.